B sets simplify A complement union B complement intersection A complement. All right, so I'll be doing a lot of talking here, but if you have any questions, you can just unmute and come in at any time. All right, so let's tackle this one. So I'll pick a blue pen. So then we are going to say, okay, so A complement union B complement, all that complement intersection A complement is equal to, all right? So we just have to distribute this complement that is outside into the bracket. So you end up with A complement, and then the union becomes an intersection, then B complement, intersection A complement, all right? So doing that, A complement, they cancel, so you end up with an A intersection B complement becomes a B, and then this should be intersection A complement. Now we need to rearrange these. We are allowed because the operator, the intersection operator is commutative, so we can group terms that we want, then intersection B. Now, if I may ask you, complement means things that are not in that set, all right? Are we together, guys?
Yes.
Okay, so
yes.
I want you to tell me what would be this part. What is A intersection A complement? What do you think is the answer there? A intersection A complement. What do you think is the answer for this part in brackets? Okay.
Is it an empty set? Empty set.
Should be an empty set. For example, it's correct because imagine if I have a universal set, okay? If I have something like this, let's consider this big box as the universal set, and we have a set A. Let's call this set A. Oh, come on. So let's put numbers 1, 2, 3, and then 4, 5, 6. Now, if I'm going to list, A is equal to the elements 1, 2, 3. Are you following?
Yeah.
Okay. So tell me, what are the elements of A complement from this example that we are doing?
4, 5, and 6.
Okay. So A complement would be 4, 5, and 6. These are the things that are not in set A, right? Now, what is A intersection A complement? We want all these things that are common in both A and A complement. So clearly, it's empty. There's nothing in the intersection. Can you see that? If you compare this and that, A intersection A complement is empty. You can write it like that or this sign. Okay, a 0 that is cancelled. So coming back to this problem that we are working on, so A intersection A complement is just empty, intersection B. Now, we need to simplify this further. Now, if I take an empty set, okay, let me just illustrate here. If I take an empty set and I want to intersect it with a certain set, say for example in this case, let's do A, the one that we just found here. An empty set does not have elements at all, but A has elements 1, 2, 3. So what are the common elements inside the empty set and set A? Because that's what the intersection is, right? So what do you think is the answer here? For empty intersection A, what do you think is the answer? There is a theorem which says that the empty set is an element of every set. Do you know that?
Yeah.
Okay, so it means in every set, but normally we omit it, we don't write it, but it's there in each set. So we have the empty set that is written like that, and there is another empty set that is there. So the intersection of an empty set with any set is empty. Okay, so let's come back to the problem. So empty set intersection B will be just empty. Okay. So, and remember when we were doing some revision before, we once said that intersection can be viewed as a multiplication operator, and the empty set can be viewed as a zero. So 0 times anything is a 0. Do you see that?
Yeah.
Okay, perfect. All right, so let's move. If you have any questions regarding any of these problems, please let me know. Okay, so solve for x in the inequality 1 over modulus of x minus 1 is greater than 2. Express the solution in interval notation. You could have seen maybe this question somewhere, but let's see the proper way of tackling this. Okay, now the best way to deal with the fractions of this nature is to kind of dissolve fractions first. You know, if you are given a problem with an inequality with fractions like this, the best way to deal with this is to kind of dissolve fractions. How do we do that? We multiply both sides by the common denominator. All right, we multiply this side by modulus of x minus 1, and also multiply this side by modulus of x minus 1. So eventually you end up with 1 greater than 2 modulus of x minus 1. Okay, now what do you do next? We can just divide both sides by 2, and then we end up with, all right, so I want you to see that also we end up with half greater than modulus of x minus 1. This is just the same as writing. We normally prefer to have variables on the left. Okay, this modulus is less than half. It's one and the same thing. Don't get confused. Okay, these two steps are exactly the same. It's just that I wanted the variables to be on the left. Okay, so there is a theorem, if you remember from your lectures, if you have something like modulus of x, say less than a, this is, or this implies, okay, this implies that sorry about that, you can place x in between, and then right at the back you will have a negative a, and right in the front you have a positive a. Okay, if you have a modulus sign of a variable less than a constant like that, then you can treat it like that. So we want to apply the same for this problem that we have. This time around, we keep whatever is inside the modulus in between. So it's x minus 1. Then we put this sign, the less than sign, and the greater than sign right at the back. Then to this constant, we apply a negative half, and then the one in front becomes a positive. We are just applying this property that I explained here. This is how we simplify this stage. Okay, now we need to solve for x. So then this becomes, we add both sides. We want to leave x, we want to make x subject to formula actually. So we add everywhere, we add a 1, so that in the middle will remain only an x. So we will have minus half plus 1 less than x minus 1 plus 1 less than half plus 1. So if you do the math, you're going to see that half is less than x less than 3 over 2. Okay, so therefore we are asked to leave your answer in interval notation. You can leave your answer here, or this is kind of an inequality form. The interval form would be x is an element of the interval from half up to 3 over 2. We use small brackets because the inequality is not taking the endpoints. Okay? So this becomes our appropriate final answer, because this, of course, it's an interval, kind of, because it's using inequalities there, but the best way to do it is to kind of write it as x is an element of the interval from half to 3 over 2. Okay, I hope you guys are following.
Yes.
Okay, so find the real values of k for which the inequality has real roots. Okay, so let's rewrite the quadratic expression. It's x squared plus, in brackets, k plus 1 x plus k squared equal to 0. So now for real roots, the discriminant, normally we write it as a small triangle. The discriminant, or capital D if you want, the discriminant should, for real roots, the discriminant should be greater or equal to 0. All right, and we know that the discriminant is none other than b squared minus 4ac. It comes from the quadratic formula. Okay, so now let's do this. So what is b according to this quadratic equation here? Our b is k plus 1. So we say k plus 1, this is b squared minus 4, a is 1, and c is k squared. And for real roots, we require that this should be greater or equal to 0. So let's simplify this. This becomes k squared plus 2k plus 1 minus 4k squared. This should be greater or equal to 0. We subtract k squared minus 4k squared is minus 3k squared plus 2k plus 1 greater or equal to 0. Now we have a problem factorizing this expression where the leading term or the coefficient of the quadratic thing is negative is problematic. So what we do is we divide everywhere by negative. This becomes 3k squared minus 2k minus 1 is greater or equal to 0. Okay, so then if we factorize, this is the usual quadratic formula, the usual quadratic expression that you guys are used to. There are several methods of factorizing this thing. You can take the 3 and multiply it to a negative 1, you have a negative 3, and you have negative 2 in between. So you're looking for two numbers which when multiplied will give you negative 3, and added will give you negative 2. So I think it's 1 and negative 3. Okay, so then if you use those ones, then you have, let me see, 1 minus 3. Okay, so if you do the factorization, you end up with the 3k plus 1 and k minus 1 greater or equal to 0. Okay, so maybe I don't want to confuse you. Let's do the appropriate thing. So I would say 3k squared and rewrite this negative 2k as plus k minus 3k minus 1. K minus 3k is exactly here. I just put k and k here. So this k is positive and this negative 3k is negative here. You can do it your own way, you know, the way you were taught in high school. You will always get the same answer as mine. So here we can factor out the choice is ours. Actually, we can factor out k and we end up with 3k plus 1, and then for this one we factor out negative, you end up with 3k plus 1 greater or equal to 0, and then you factor out one of these brackets is common and the other one becomes k minus 1, like that, greater or equal to, ooh, something is not right here. Abigail, what's wrong here? Can we see something that is not right? Abigail, what happened? Okay, you see, look at where I'm putting the star now. It was negative 3k squared plus 2k plus 1. But we changed at this stage to...
Yeah, you didn't change the
Yes.
direction of the inequality sign.
True. Okay, it was supposed to be inverted. That's correct. Let's invert it like that, and then this becomes less or equal to 0. You should be very careful with these inequalities. Now, find the real values of k for which the... Okay, so we have two critical points. You can just check on the number line. We have two critical points. One is minus 1 over 3, okay, and the other one is a positive 1. Okay, so if you pick any number that is below negative 1/3, say minus 2, put minus 2 in this expression. You have minus 6 plus 1, that's minus 5. Minus 2 minus 3, minus 2 minus 1 is minus 3. Negative and negative will give you positive. So it's positive here. So it's completely opposite. So this region is out. We don't take it. All right? Because we are getting some positives here. And yet we are looking for less than or equal to 0. So we check the region in between. There's a 0 in between. So we can use 0 for k. Then you get a 1 there. 1 times negative 1. Then in this region we're getting negatives. Okay. Don't draw these Popeyes in the exam, okay? I'm only doing it for fun. So in between here we're getting negative. So this region we take it. But above 1, if you check, if you, let's pick a 2, put a 2 in this inequality, you have 6 plus 1, which is a 7, 7 by 1, which is positive. So we're getting positives everywhere here. So this region is rejected. So the only answer would be that k, how do you write it? We will say k is between less or equal to minus 1 over 3 or less or equal to 1. You can leave your answer like this, or you can write it as k is an element of, we put square brackets now because we have less or equal to, so there's 130 there, semicolon 1. Okay, so this becomes our answer. Are we together?
Yes.
Okay, perfect. So let's see here. We have this logarithmic equation. The question is to, or the question requires us to find the, or to solve for x. Okay, so there are two. Okay, there's another way of doing this. If you look at it, it's a quadratic equation in log x. So I can just say let y be equal to log x, such that the equation becomes 2y squared plus 3y minus 2 less than 0. Okay? Then let's try to factorize. I'm looking for, if I say 2 times minus 2, I'll get a negative 4. If I add, I should get a 3. I'm looking for two numbers. What are those two numbers? Negative 1 and a 4. If I add them, I'll get this 3. So that's correct. So I'll say 2y squared. Instead of writing this 3y, I'll say negative y plus 4y minus 2 less than 0. The choice is mine. I can factor out a y. For these two, I'll get 2y minus 1. Then for these ones, I'll factor out a 2. I'll get 2y minus 1 less than 0. So combining, I'll have 2y minus 1, y plus 2 less than 0. Again, we implement the number line, which is very, very effective. So we draw a small number line. We have critical points at half and minus 2. So negative 2 is further down, but half is somewhere here. And remember, 0 is somewhere in between. So let's try. Let's pick any numbers that we want on the number line. Further below negative 2, let's pick, say, minus 5. Minus 5 times 2 is minus 10. Minus 1, that's minus 11. 2 minus 5, that's minus 3. Minus 11 times minus 3, that's something positive. So I'm getting positives here, but I want negative. Okay? So this region is rejected because it doesn't satisfy the inequality. Then let's pick any number in between. Well, let's pick a 0, for instance. Put a 0 there. You have minus 1 from this bracket. 0 there, you have a 2. Negative 1 times 2 is negative 1. So in this region, I'm getting negatives. So this is the region that we want. And anywhere else above half, let's try a 1 there. 2 times 1, that's 2, minus 1, that's a 1. 1 times 3, that's a 3, positive. So these are positives, but the only true region, therefore, y is greater than negative 2 but less than half. You can leave your answer from the inequality with that. But remember, our y is our log x. We were given this problem in terms of x, so we have to revert back. So we are going to say minus 2 is less than log x less than half. We just replace y with log x. Now, what do we do? Remember, when the base is not indicated, the natural base is a 10. Normally it's not written, so the 10 is there. So to get rid of log, we take this 10 onto the left hand side, and when it gets there, it becomes the base, and whatever is there becomes the power. So it becomes 10 to the power negative 2 less than x less than, we take again 10 to the front, so it will be 10 to the power of half. Okay, so simplifying this further will give us 1 over 100 less than x less than square root of 10. Okay, so this becomes our final answer. We have solved for x. Remember, we don't leave our answers in terms of y. We have to always answer the question. Determine the term. I hope you guys are following. I'm just cruising. I'm assuming that we are together.
Yes.
Okay. So if you have any problem, anything that you don't understand, please just unmute and say anything into your gadget. All right. So let's go back to question number. It was question number 2B. All right.